Hey guys, welcome to Code Decode. Today in this video, we will be looking into everything about load balancers from scratch till end. Being a Java developer or backend developer, you will always have to face the load balancers while you are developing your applications, be it a microservice application, be it the cloud-based applications, or even if you are facing some system design interviews which you are bound to face after 2 or 3 years of experience in your IT life. So let's get started and see what load balancers are all about. Please like, share and subscribe to support this. What are load balancers? Let me start with an example only. Suppose you have one of the microservice here. So suppose we have an example of microservice of X Nations microservice and Citizen microservice. Now we know that load will obviously increase because it has loads of people trying to register your citizen data or trying to book a vaccination center. You know that only one server, even with a very high-end best processor, best RAM, everything very good, you will not be able to handle all requests at 24/7. You cannot do that. So for that reason, for sure you will need to scale your application. And to scale, you have only two options: vertical scaling and horizontal scaling. If you want to know more about vertical and horizontal scaling, you can let me know in the comment section. I'll create a separate video on that. But currently understand that vertical scaling is to increase the configuration and horizontal scaling is to increase the number of servers. What I always prefer is there is no end to the number of requests that is going to hit in the future. So always try to focus on the horizontal scaling. So here we are using multiple microservices instances rather than increasing the configuration of one server on which microservice is deployed. So here we have three instances of microservice 1 and there is a client. Now what is the task of load balancer? So load balancer sits in between. Load balancer's task is to redirect the client request to the currently not so busy and healthy microservice server instance available. So when we want to scale our applications, we have multiple instances of the server deployed. Now to evenly distribute your incoming request to the healthy server is a big task. And this big task is done by load balancers for us. The load balancer's responsibility thus is to equally distribute each client's request among the pool of available servers. So these are the servers we are having. Now we know that there are multiple client requests who is going to hit our server for our registrations and booking procedure. To avoid the crashing of servers, load balancers carry out the functionality of equally distributing all such requests coming from multiple clients. So there will be multiple clients. So all these requests will come to load balancer and load balancer will finally distribute it to which particular microservice is healthy and available. Hey guys, there is a super amazing app called as Next Level, recently launched by Unacademy for you. Next Level is gamified coding competition platform for you to showcase your expertise and skills and get professional ratings. The better is the professional rating, the better is your job opportunities. Next Level League will start from 11th of March. This league is one-day contest. Click on this register button to register for the upcoming league and on banner to see the prizes. Play one-on-one games in the league and compete for the top score. The more you win, the higher is your rating and you get a chance to win prizes. Top 100 player will win prizes where first prize is Apple MacBook Pro, second is Apple iPad Air, third is Kindle White Paper, fourth in all of them are Amazon gift cards worth rupees 5,000 to 1. These are winners from the last season for both backend and front-end development. They all received Apple and Kindle goodies along with interviews for the awesome companies. There are many coding competitions on the application. All you need to do is participate in these coding competitions, compete with the people, win the coding rounds. The more you win, the better is your rating. The better is your rating, the more is the job opportunities unlocked for you. Yes, they have multiple partners across the multiple domains like in IT services like HCL, TCS, Infosys, SAP Labs, and many more. They have also introduced power-ups so that when you lose your game, you can use those power-ups to restore your rating to the original one and prevent them from going down. You can earn power-ups by inviting your friends. Challenge them to coding competitions. The best part is the app is completely free. Thus, load balancer becomes the first point of contact within a data center. Now don't get confused with this word data center. This is usually used when you deploy your application to cloud or to your private cloud. There is a data center which is nothing but a group of multiple servers having your applications deployed and all the client requests comes to that particular data center in that particular geographical location where you live. So for example, this is data center for India. Now there can be a chance that you do not have just people from India. There can be a chance you have people from the nearby countries like say Sri Lanka. So there you have one more data center at Sri Lanka. So you can have an application which is distributed globally. You can have one data center in US if you have people who wants your services in US. Then hitting a request from USA to the data center in India, which is geographically very wide apart, will give a poor latency and poor user experience to the users. And hence you can create your own data centers at US also. So that's where data centers come into picture. So the task of load balancer is the first point of contact between the client and your application. So in a data center, the first thing that is interacted with from the client is the load balancer. So it's the first point of contact. If the service processes a few hundreds or few thousands of requests per second, then load balancer is not required. So this can be asked in an interview, that if your application that you are designing is handling 1000 requests per second, so will you use load balancer or will you not use a load balancer? So answer should be no. We need not use a load balancer at this point of time. We can use a high-end configuration server. One server will be enough to handle 1000 requests per second. That's how good processors are nowadays. But if it is more than that and is very much variable, you can scale, and when you scale, you always need a load balancer if you are scaling horizontally. What are the advantages of load balancers? So advantages of load balancers are scalability. So scalability is achieved through load balancers. If there is no load balancer, even if you do the scalability, your request might end up reaching at only one microservice, and even though you have multiple microservices available, you will not be able to redirect it properly and evenly among these without load balancer. So scalability is nothing without a load balancer. Then availability, the system continuously function even if some server has a problem or to go offline. Now these failures are removed by the load balancer. What happens is, suppose this microservice 1 is down. Now if this particular instance microservice is down, then the task that is done by this particular load balancer is to redirect that particular request from the failed microservice to the healthy microservice instance, and hence make sure that your system does not get an internal server error or sorry, this microservice is down error kind. It rather gives it to the healthy microserver and your request is getting fulfilled. Hence your system is much more available, all thanks to load balancer, because he is capable enough to ping him, ask him, are you healthy? If says yes, are you busy? If says yes, then I am going to redirect to another person. So that task of making your application much more available so that your request is fulfilled is what good availability says. Next is performance. Yes, even the good performance means the faster response time. Now what happens if your request keeps on going to second instance of microservice 1? Your request keeps piled up in a queue and you will get a slow response time for the done request, which is a very bad user experience. To prevent that kind of bad user experience or slow response, there comes the load balancer. It checks which particular server is free, it's empty to take your request, and will redirect you to the empty one so that you get your response quickly, and that enhances the performance with the faster response time. Now where can you use load balancers? Only and only here in the initial part of the data center? No, this load balancer can be used at multiple places. So suppose if you have an API gateway, there can be a case that there are multiple API gateway instances. So before the API gateway also, you can have the load balancer who can redirect you to the proper application gateway. Now from application gateway, you know that you will be redirected to some microservice. So between application server and microservice, again you can have one more layer of load balancer. And again between multiple microservices, suppose microservice 1 interacts with microservice 2. So there also you can have a load balancer there. Now there can also be a case that microservice 2 interacts with the database. You have multiple DB instances because the users are getting increased. In that case, to decide which particular database server your request has to go, again load balancer comes into picture. So there can be a load balancer here also. So you can see there are multiple places your local load balancer can come into picture. So considering a microservice architecture, if there is a client, API gateway, microservice 1, microservice 2 and database connection, then you can have between client and API gateway a load balancer layer. From API gateway to microservice 1, a load balancer layer. From MS1 to MS2, you can have a load balancer layer. And from either MS1, MS2 to a database, multiple databases instance, to redirect to the proper database instance which is healthy and free, there can be another load balancer layer. Now a very important interview question. Looking at this, suppose this is the load balancer I'm using. This is your microservice 1, 2 and your databases. Now consider a situation, your microservice 1 is working perfectly fine, 2 is also working fine and DB server is also up and running. What if your load balancer is down? All your client requests will not be able to reach any of the microservice or the database. Why? Because there is a single point of failure. If in any case your load balancer is down, it becomes a single point of failure. All your requests will be denied because there is no load balancer to properly redirect it to any of the microservice instance. So isn't this a single point of failure, and this is this not a very much big threat to the application? Because if this fails, then your whole system goes down even if there is no mistake from your end. Answer is yes. Implementing load balancer with just only one instance is a single point of failure. That is why in real-time IT world, always load balancers are typically deployed in pairs. So that when first load balancer fails, there is another load balancer who is capable enough to replace the failing load balancer. So a backup load balancer can always take over in the event the primary load balancer is failing. And in the worst case, if both are failed, manual rerouting can also be done. So in enterprises, in real world, we deploy cluster of load balancers that constantly monitor each other's health using the heartbeat communication to maintain the high availability of system as well as with load balancers. So we don't deploy one load balancer, we rather deploy multiple load balancers, making a cluster of it as a backup. Now if this particular load balancer dies, all your requests will be redirected to this particular backup load balancer, and from here a particular microservice will be called. So this is how the backup load balancer, when you deploy, works as the backup for those which is failing and hence prevents your whole system to go down. Now one of the important interview questions. Type of load balancers you can use. There are two types of load balancers, the global load balancers and the local load balancer. Now I have told you, if your application is geographically very limited, like for example a vaccination center, only Indians can book it for India, right? Not the NRIs cannot do it from USA and book a vaccination center in India. So your application is not geographically distributed. Your users are only from one geographical location. Hence you can always go with the local load balancer. But if your application is something like Twitter, Instagram, where the users are not geographically limited to India or US, they are globally distributed. They are also in India, they are also in US, they are also in Sri Lanka, multiple geographies. In that scenario, your application has to be deployed in multiple data centers located at different geographies so that the response time is less for the people in that particular geography. Now imagine you are using Instagram, it's having its data center just in USA. From India, how much time will it take for a server who is deployed in USA data center to respond to your image that you're trying to see for your friend? It will be a very bad response time. It will be a very bad user experience. To prevent that, usually companies deploy their application servers in multiple data centers across geographies. So there your local load balancer might not be of much use, right? It will be the local load balancer who will decide your client belongs to which particular geographical location, and based on that geographical location, it will redirect your request to the proper geographical location which is very near to you. So that decisions or that session or client data session maintains, everything has to be done by the load balancers, but not the local one but the global one. So the first client request goes to global load balancers, then it is given to the particular data center, and from that data center the local load balancer takes up the redirection task. So that's where local load balancer comes when your application is distributed across geographies, and local load balancers is within the same data centers. So it completely depends upon your application. How load balancers distributes the request? Now a very important interview question. You have 3 instances of microservice 1. How does this load balancer decide this client request coming from client 1 has to be distributed to which particular instance of microservice so that it does not overload one microservice? There are multiple ways which load balancers can implement. The first is a round robin scheduling. In this approach, each request sequentially is forwarded to a different pool. So for example, in load balancer, having the round robin scheduling, the client request 1 will go to instance 1, client request 2 will go to instance 2, client request 3 will go to instance 3, client request 4 will go to again instance 1, 5 will go to instance 2, 6 will go to instance 3. So this is a round robin fashion. Each and every request is sent to another instance in a round robin fashion and in a circular way, 1 2 3 1 2 3, that's how. But there is a problem to it. There can be a chances that my microservice 1 instance 1 is very highly configured with a very great processor. It has capacity of twice handling as that of instance 2. Then it will be wrong, because you are underutilizing your very highly costly server. You are not utilizing it properly. You can give 2 requests to it, 1 to it and 1 to it, because these are normal configured, but this is a very high end configured server. So if you're paying that much, use it that much. Why to keep it empty? Then comes the weighted round robin scheduling. That means if you have some servers with better equipments to handle the client request, then you assign a weight to that node. Now if this weight is 2, this is 1 and 1, then request 1 and 2 will be given to this, 3 here, 4 here, 5 and 6 will be given to this, 7 here, 8 here. And this is how the weight decides the number of requests the load balance is going to assign to that microservice. If high end, the more request; if lower end, the lower. So it's weighted round robin. Third is the least connections. Now suppose a client is creating a connection and it is creating a connection for a very long time. So microservice 1 is getting blocked for a very long time by client 1. Now client 2 comes, so you'll redirect it to 2, then to 3, now 4 comes. This connection is still alive while 2 and 3 is empty now. So this is having some connection with the client, but these are empty. They are not having connections much. So if you append the 5th of your request to microservice 2 rather than microservice 1 in the round robin fashion, you will be having a better chance to get response. So one with having least number of connections in the queue has to be chosen, rather than just going round and scheduling in one after another. So these are the 3 ways. There is also one more way which is not very efficient, and I never appreciate this. This is based on IP addresses. So what this load balancer do is, it calculates the IP address, it calculates the hash, checks on the basis of the hash number which particular hash code this particular microservice instance is given. So suppose hash code for this is 0, this is 1, this is 2. If the hash code of this request comes as 2, so it will go here. If it comes as 0, it will go here. But what will happen if your 2 IP addresses have the same hash? Then rather than having it distributed among the 2 microservices where both are empty, you end up having the hash as 0 for both, and you end up having 2 requests in the same microservice instance, which actually denies the essence of load balancer distributing it evenly. So that is why I do not appreciate this hashing at all with IP address, be it anything. I do not appreciate this. You can always use any of these 3, either the round robin, weighted round robin, or the least connection. Now a very important question from interview perspective. How do you implement a load balancer? So you know that a load balancer is the one who redirects the request from client to server. Now depending upon the incoming request, the structure and the need of the application, there can be 3 types of load balancers. Hardware load balancer, software load balancer, and cloud based load balancers. The hardware based load balancers are very expensive. So what they do is, in this load balancer, they create one server which is dedicatedly doing only the task of load balancing. It is very efficient, very good performance, but very, very costly, because you are deploying one whole of the server as the load balancer. Simultaneously, you have to create one more copy as a backup. So you just don't have the one load balancer system, but you have 2 load balancer systems for 3 instances of your microservice. It doesn't make sense, right? So they are very expensive and they are standalone devices. They offer a very great performance advantages, but it is very difficult to configure it. It takes a lot of money. A huge effort is to be put with such servers, because availability can be a problem, because the backup is also one more system that you have to put. If you do not put one more backup server, then your availability will be gone. If your server is down, everything is down. So backup is also a problem, and it is also less adaptable due to maintenance and operational expenses, because you have to maintain this extra 2 servers now apart from your own server. I do not appreciate load balancers as a hardware, a complete separate server standalone, because then you have to handle more and more of your physical server with high maintenance and operational cost. A better option is to go to either software load balancers or cloud based load balancers. Now software load balancers are much more adaptable and affordable. What will it do? It will have one of the server performing multiple tasks but also doing the load balancing task. So not a separate hardware but a software implemented on a particular hardware, which actually has the coding part done, where your request will be redirected to the healthier, better microservice instance. So this is much more affordable. This is much more scalable, because what if there is a case that even load balancers is not able to handle these many requests? Then what can you do? You can incorporate that software application of load balancing into one more server when the request increases. At that point of time, you can increase the number of servers, and when the request goes down, maybe at night or sometime, then you can reduce the load balancer servers having that software deployed. And also creating backups are also easy, because you just need to have one software up and ready. Whenever the first one is down, the second shadow load balancer is capable enough, only with a little cost and amount, to be available to handle your redirections. The best part of it is nowadays cloud starts giving you load balancer as a service. Many cloud providers out there provide this load balancer as a service, and they provide you a service level agreement. Here what happens is, in first and second case with the server or the software, in both the cases you have to maintain it. If the server is down, you have to find out why server is down. If the software is down, you have to fix the bugs in the software. But with the cloud having it as a service, your headache is gone. Every maintenance, everything is done by cloud. You just pay for what you have used for the load balancing part. And also you get a service level agreement that 90% time your load balancer is up and running. So don't worry, your application will also not fail because of single point of failure of this load balancer. They are simple, better management, better cost effective and flexible in terms of monitoring and handling such services. To decide which load balancer you have to use is completely on your requirement. If your requirement is you are just having everything on your own premise, then using the cloud just for load balancing doesn't make sense for us. Secondly, you have a very high requirement of making it highly available at all point of time with high-end configuration. Then even hardware you can think of, but usually we don't. So the best part, I can come in between for both hardware or the cloud. If you have your own premise data center, then you can go for the software load balancers. But if your application is completely on cloud and you are already using cloud services, then the best part is to use the cloud load balancer only. With few more cost on your pocket, you will be able to get rid of all kinds of headache you comes with the hardware or software load balancers that you have to manage. That was all about load balancers. I have many more things to cover, like database, scalability, rate limiters, the caches, the databases, NoSQL, MySQL, which to use, when to use, which is also going to be used in the system design. You can let me know in the comment section. I'll create another video on that. Thank you.